Okay, so let's take a look at anaerobic respiration. This is the incomplete breakdown of glucose in the absence of oxygen to produce energy. Now, anaerobic respiration, right, without oxygen, this occurs in the cytoplasm, okay? So here is the direction. So, with oxygen, we go in the mitochondria. No oxygen, we're not going to go into the mitochondria. So essentially two types of organisms when it comes to this doing anaerobic respiration. One is called a strict anaerobe, and this is an organism that only uses anaerobic respiration to extract energy from molecules. So they only use anaerobic respiration. The other is a facultative anaerobe. This is an organism that can use anaerobic or aerobic respiration, and this depends upon oxygen availability. Now, we're what I guess you would technically call us facultative anaerobes, but the reality is we're probably strict aerobes because if I cut off an oxygen supply to you or if one is cut off to me, we're not going to survive for very long. Okay, let's take a look at the steps in anaerobic respiration. The first step is glycolysis. That doesn't matter whatever during aerobic or anaerobic respiration, you're going to do glycolysis first. The second step is a fermentation step, all right? And there are two fermentation steps and depends on the organism that we're talking about. So the first is called lactic acid fermentation. So this is an anaerobic step after glycolysis that reduces pyruvate into lactic acid or lactate, all right? So what happens here is you go through glycolysis, and then you produce your two pyruvates and you produce your two NADHs, just like we talked about with glycolysis before. But now that NADH cannot go to electron transport chain. But we still need this molecule, NAD, to come back to glycolysis to grab more electrons. So we actually put those electrons back onto pyruvate here and we make lactate or lactic acid with this. Now this is done with bacteria to make cheese and yogurts. We do this in our muscle cells during strenuous exercise, all right? And then our liver is going to convert that lactic acid back into pyruvate, which is a usable molecule for us. The other type of fermentation is called alcoholic fermentation. So this is the anaerobic step after glycolysis that reduces pyruvate into ethanol and carbon dioxide, okay? So in this, right, we're still going to reduce that NADH to NAD. And now, in this case, instead of making lactate, we make ethanol and carbon dioxide out of this. Okay? So we use this with yeast to leaven bread, so making the bread rise. That's what the carbon dioxide does. It also produces alcoholic. The ethanol is used in alcoholic beverages and as a gasoline additive. All right? So let's look at some advantages and disadvantages here. So advantages of anaerobic respiration. We get a rapid burst of energy, okay? So this is what we do, like with strenuous exercises, sprinting, lifting weights. We're going to switch to anaerobic respiration. But it produces a low yield. So it also produces ATP when oxygen is low supply. So we can still have some oxygen, produce energy, even if we're not getting a lot of oxygen. Disadvantages. It's a low yield of ATP. As you can see on this whole thing, here's glycolysis, here's the fermentation step. We're only making 2 ATP in this, all right? So one glucose anaerobically only produces 2 ATP. Aerobically, we're gonna make 30 to 32 ATP. And lastly, the products are toxic to cells. So, the ethanol could kill the yeast, the lactic acid can kill the bacteria, all right? So the lactic acid with us causes our muscles to fatigue, meaning they're not going to contract even though we still want them to. All right? We have to wait for the lactic acid to fuse out before we can contract those muscles again. All right, let's look at muscle fiber types. All right, so we have fast twitch fibers and slow twitch fibers. So fast twitch fibers, these are muscle fibers that respire anaerobically. So if they're respiring anaerobically, right, they're going to be relatively low in mitochondria, blood capillaries, and this protein known as myoglobin. So myoglobin is a protein that stores oxygen in the muscle cells. Here's something that's counterintuitive. When we contract muscles, we actually pinch the blood vessels that are delivering oxygen to those muscle cells. So the stronger we contract those muscles, the less oxygen they actually get. And so because we're getting less oxygen in those muscles, we have to shift from doing aerobic respiration to anaerobic respiration. So we do strenuous exercises, sprinting, lifting weights. That's we're going to shift to doing a lot of anaerobic respiration during those time periods. And that's where those fast twitch muscle fibers kick in. All right? So those muscle fibers, once again, relatively low in mitochondria because we're not going to do aerobic respiration anyway, blood capillaries, which would deliver oxygen to them, and myoglobin, which is a protein that stores oxygen. So low in all this, okay? Look at slow twitch fibers. Slow twitch fibers are muscle fibers that respire aerobically, all right? So they're going to be relatively high in all those areas that the fast twitch muscle fibers were low in. So they're going to be relatively high in mitochondria, blood capillaries, and myoglobin. All right. So, if you've ever, gone someplace to eat some chicken, you might have noticed that some of that chicken is dark meat and some of that chicken is white meat. And this has everything to do with what those chickens use those muscles for. So, dark meat on a chicken is the legs and the thighs, where the white meat on the chicken is the breast and the wings. Now, if you think about chickens, they walk around a lot, right? So what they want to have there is slow twitch muscle fibers. So if they have to walk or run, all right, but they walk primarily most of the time, all right? So you don't want those muscles to fatigue very quickly, which can happen with fast twitch. Now, if a predator has come by, the chickens are going to fly up to a higher perch. The chickens are relatively heavy birds, and so they're going to do quick, powerful movements. So movements like this. They're going to use their arms, they're going to use their breast muscles, their pectoralis majors, to get them up to a higher perch to get away from that predator. Quick, fast movements. And so if you're doing quick, fast movements, you want to do anaerobic respiration there. And so this is why the dark meat is dark. It has to do with the high myoglobin content that is used by these slow twitch muscle fibers. And white meat is white because it has a low myoglobin content because we're doing anaerobic respiration in those muscle fibers, and those are those fast twitch muscle fibers. So why white meat is white and dark meat is dark has to do with myoglobin content, which has to do with what those chickens are using those muscles for, whether they're slow twitch or fast twitch. So when we talk about us, most of us are about 50-50 here. About 55% slow twitch, 45% fast twitch. Okay, now differences in this are due to genetics and also your training. If you're a marathon runner, you can get this up to about 82% slow twitch, 18% fast twitch. If you're a sprinter, sprinters are going to have 37% slow to 63% fast, right? So they're not going to have that dramatic difference that we see with marathon runners, and that's because when you're not sprinting, you're walking around, you don't want those muscles to fatigue very quickly.